Hi all, I'm super excited to be presenting talk on churn analysis. In this talk, we'll be seeing how to build an end-to-end no-code tool which can help businesses identify churn. So before I get into the details of this talk, here is the small introduction about the team that worked on it. So myself, Padmaja Bhagwat, I'm currently working as a data scientist at Glance. Here I work on providing personalized content recommendation to our customers. And Bhargava here is my mentor. He is currently working as VP of AI platform at Axion Ray. He holds expertise in building customer journey analytics products, which empowers small and medium term businesses. So, this is how today's talk is going to look like. We will be starting with the business context, like understanding the reason behind performing churn analysis, why it is so important for businesses to identify churn at the right time. And once we understand the business context, we'll then move on to the exact process, the steps through which we perform this churn analysis. Then we'll be looking into the demo of the application that we built. And finally, we'll be going through the code that enabled this entire system. So we all know that this pandemic has had huge adverse effect on most of the businesses, especially the small scale businesses are the ones who are affected the most. And during such a situation, it becomes extremely important for as for a business or for a company to ensure that they retain their customer for as long as possible. And therefore, in order to do this, we have built an end-to-end tool which would help identify the customers who are about to churn, and this would in turn help businesses take a proactive measure in retaining their customer rather than taking a reactive measure. So before I get into the functionalities of the tool, let's take a step back and understand how a typical customer engagement lifecycle looks like. So this starts off with building the product awareness. When somebody is launching a new product, they would typically advertise it through the newspaper, via billboard, or any other means. And when the customer gets aware of the product that you're offering, they start engaging with the product. They might visit your website, might explore what are the services or features that you're offering. And slowly, if the customer likes what you're offering, they might get converted into the paid members. And some of those customers will end up using your product for a very long time, and we call those customers as our loyal customers, right? So this is how you would typically want the customer journey to look like. But there are several situations where some of the customers might stop engaging with your product, and this could be because of several reasons. So first step is when the customer visits your website or uses the product, but for some reason they don't use it any further, and that's what we refer to as abandonment. And the second kind of disengagement is when the customer likes what you're offering and therefore subscribes to the trials or whatever free trial that you're offering. But after the trial period gets over, they do not get converted into the paid members. Now, these two kinds of engagement, definitely they hurt the business, but the one that affects the most is this churn. So where the customer who is loyal to your product, who has been using your product for several years, all of a sudden they stop using it. Now these are the ones who have huge negative impact on the business. So the underlying idea behind all of this is that it's much less expensive to retain the existing customers than to acquire new ones. So the goal here is to proactively identify the customer who is about to churn. What I mean by that is the customer who has been active onto your system for a very long time has now slowly started to disengage with the product and might eventually stop using it altogether. So the tool that we have built help us identify this customer who are at risk of churning. So now that we have understood the reason and importance behind doing the churn analysis, let's see how we can build this tool using Python. So these are the four major steps that are involved in building this tool. First is pre-processing of data, where we'll be converting the data into the format that our model can understand. Second is we'll be experimenting with different kinds of models, and today we'll be majorly focusing on survival analysis model. Uh, And third is predicting churn using the model that we have built. And finally, building a web application which would help us track the customers who are about to churn in on the real-time basis. So now that we have looked at different steps that are involved in building this tool, let's actually have a look at the demo of this application and understand how each one of these components is built. Now we will be going through the process of churn analysis step by step. So the first step obviously would be to pre-process your data. For today's talk, we'll be using an open source data called as telecom data. You can easily access it from Kaggle. So this is how the data looks like. So let me tell you, whatever step I'll be explaining in next couple of minutes can be applied to any kind of data as long as you ensure your data contains the following features. First is it should contain this customer ID that uniquely identifies the customer. And second, it needs to have this feature called as tenure. Now, this tenure indicates has slightly different meaning for different kind of customers. Okay, for the customer who has already churned, let's say the first customer has churned, this tenure period of 2 indicates that the customer was using the product just for 2 months. And after that, the customer never came back. Whereas for the customer who is not yet churned, let's say the second customer has not yet churned, the tenure period of 34 months indicate that the customer has been using the product from past 34 months and will continue using the product in the future. So there is a subtle difference between these two, but it's really important to understand this in order to do correct kind of prediction. And finally, we need to have this column which says whether the customer has churned or not. So as you can see, most of the features in this data are categorical. That's why we have done a simple one-hot encoding of this categorical variables. So Python provides this very useful function. So it is this function is a part of pandas, which says all you have to do is pandas.getDummies, send your categorical variables, and there you go. You get one hot encoded features out of it. So we haven't done any pre-processing over our continuous variables. It's kept as it is. But depending on the complexity of your data, you can either choose to do the simple one hot encoding, or you can do a lot more standardization, normalization. Or if your data contains a time series data indicating how the customer made purchase on your platform, you can go ahead and explore this package called as TS Fresh that is best in getting the features out of the time series data. So now that we have done this basic pre-processing and we have converted the data into the format that can be understood by the model, let's directly jump into our model. So by looking at the data, you might think that, okay, this is a simple classification task. So there are already a bunch of libraries or models already available for doing this kind of classification task, which tells whether the customer is going to churn or not. This is wonderful, but the greatest value addition that your tool can provide is by telling when exactly the customer is going to churn with what exact probability. So this is something we really want to understand through our tool. That is the reason we go ahead with this class of model called as survival analysis models. So out of which Cox proportional hazard is the most common one or most widely used model. So in here, we won't be going in detail about the math behind the model. Instead, we will be seeing how we can use this model to build the specific end-to-end tool. So again, if you're really curious, Python provides this package called as Lifelines, which has various different survival analysis models. So all we have done is we have built a model and we have done model.plot, and it gives this very beautiful feature importance graph where you can see that on the y-axis, I have all my features. And on the x-axis, we have something called as hazard ratio. So all you have to know about this ratio is that higher the hazard ratio, greater the chance of customer leaving the system because of that particular feature.
Now we want the exact opposite. We don't want our customer to leave the system. That's when we concentrate on the feature that has a lower hazard ratio. In this case, the customer who is subscribed to 1 year or 2 year contract seems to stick with the product for a longer period of time. So let's pick one such feature called as total charges, and let's see how it impacts the survival chances of our customer. So, as I mentioned, in here you can see how beautifully this Cox proportional hazard model is able to give you a different survival function for uh, different total charges that the customer has spent on your system. So you can see for the customer who hasn't spent anything on your product, from around 10th month itself, the probability of customer surviving starts dropping. Whereas the customer who has spent a lot on your product, let's say around 4,000 rupees, till around 60th month also, the probability of customer surviving onto your product is really high. It's as high as 100%. So depending on the feature that you're interested to explore, all you have to do is you have to build such plots and see how varying that particular feature's value would give different survival curves. So I have given a link to this particular model over here. So you can read more about this model by visiting this following link. Now that we have established why we are going ahead with survival analysis model and how to build that model, let's go ahead and do our predictions. Let's pick one of the customer and see how that customer's survival chances varies over the period of time. So just a note over here, we will be doing prediction over the customer who is not yet churned. So this bunch of customers who have not yet churned are called as censored subjects. So one such customer that I have chosen here is this particular one. You can go ahead and choose any customer that you're interested to learn more about. So for this customer, when you do model.predict and send the data of this customer, the model gives this very beautiful dotted curve that you see. This is how the survival chances of the customer is varying over the period of time. Now we refer to this dotted curve as unconditioned survival function because if you notice, according to this dotted curve, at around 30th month itself, the survival chance of the customer reduces to around 90%. But if you see, the tenure period of this customer is 34 months. So ideally, till 34 month, the survival chance of this customer should have been 100%. Therefore, what we do is we take the prediction and divide every single prediction with the tenure period, and that's when we get this bold curve, which we refer to as conditioned survival function. So now you can see that till 34th month, the survival chance of this customer is 100%, and then only after that it starts dropping. So through this graph, you can get an overall idea about how the survival chance of the customer is varying over the period of time. Now, if you decide to take some action, let's say you would want to take some action when the survival chance of the customer reduces to 50%, then it is not really easy. It's not very easy to make out from this particular graph. Therefore, in here, you can see the exact month where the customer, the survival chance of the customer reduces to 50%. So here you can see that at around 49th month, the survival chance of the customer has reduced to 50%. Now, if you think that you cannot wait till the survival chances of the customer reduces to 50%, if you think you would want to take the action well before well before in time, then you can just increase the criticality of the customer, let's say to around 70%. Now what you will get in return is the exact month when the survival chance of the customer has reduced to 70%, and that is at 44th month. So we already have the data about how the customer spends on to your platform. Let's say the customer is spending 56 rupees every month. Then depending on this prediction, you can tell what is the remaining monetary value this customer has onto your product, right? So now we have seen how to build a model and how to go about making the prediction for the customer who has not yet churned. So now you know when you can, so now you know when to take an action. But what kind of action to take is also a very important question that you need to address. And this tool helps you do that. So let's go ahead and do a little bit of what if analysis. So earlier, through our feature importance graph, we have already seen that the following four features, which is payment by credit card or bank transfer, or the person who has 1 year or 2 year contract, tend to stick with the product for a longer period of time. So what we have done is here, we have picked one of the customer who has the following subscription. So this customer is only subscribed to 1 year contract and hasn't subscribed to any other major features. So what we're gonna do is let's try to revert this subscription and let's see how it impacts on their survival chances and how it impacts the monetary return from this particular customer. So when you revert, so when you revert here, you can see that just by getting the customer subscribed to this 2 year contract, their survival chances increases rapidly from around 34 months, from around 34 to 40 months, it increases to around 75 months, which is huge. And if you look at the monetary return, it more than doubles. So you can see how much important so you can see how just getting customer subscribed to one major feature would in turn enhance the monetary return from your product. So we can design our marketing and all these strategy in such a way that it targets these particular features and gets our customer onboarded onto using these features. So with this, you can ensure that the customer would end up using your product for a very long period of time. So just as a side note, you can also see that if the customer for some reason unsubscribes from this 1 year contract, their survival chances just reduces. So does the monetary return. So you would want to ensure that the customer sticks with those major features and never unsubscribes from them. So now that we have looked into the overall working of this tool, let's dive into our code. The application that I described just now had this following components put in place. First, we took input from CSV. Then we did some pre-processing using Pandas, Lifelines, and Alter. And then we built a beautiful web application using Streamlit. And all of this was deployed on the cloud uh, using Heroku. So with this, let's dive into the code directly. So onto the repo, you will find the different folder structure. The major code is in the folder called as code. So from here, the driving file or the driving function of this entire application is this app.py. Uh, from here, we'll be navigating to each and every single function that is happening. In the pre-processing of data, we are taking the CSV input, we are converting it into one hot encoding and one hot encoded features, and then we are feeding it to the model. So what is happening in model? Though the model sounded a bit complex, you can see that the model building is extremely simple. All that I've done is I've imported this Cox fitter from Lifelines package, and I've split my data into train and test and initialized my model. And after that, I've just done model.fit, which takes in our training data and the duration feature. In this case, it is tenure. And finally, the event feature, which is in this case, is whether the customer is going to churn or not. And just by sending these three parameters, if you do model.fit, there you go. Your model is ready. You do not really have to worry about the math behind it. And for the visualization, again, it's extremely simple. All that I've done is model.plot. Uh, So this is how we are building the model, and finally we are making prediction over the model that we have trained, and we are deriving what are the features that are really important, and um, how it can boost the survival chance of the customer, and how it can, and in turn, enhance the monetary return. Every now and then I have put this comment structure, which is nothing but the Streamlit code. So in this entire application, you will not find a single line of HTML or CSS code. So just by knowing Python, just by knowing a little bit of tricks about Streamlit, you can build the web application that we have built. So all that I've done is I've imported Streamlit as ST, and I've embedded such comments, whichever I think is necessary and should be displayed on the web application. I've embedded it there. So let's say uh, So I'll be showing you how easy it is to run this application, this Streamlit application. So okay, looks like my port is already in use. So all that you have to do is Streamlit run and give the application name where your Streamlit code is present, and there you go. It creates this local server, and you will get this very beautiful website up and running. So okay, let's say you want to make some changes. So let's just play around with the code and see how exactly this entire thing works. So let's change this streamlit.write to something else. Please select your data file. And after that, if you just refresh your file, this is what you see. You can see how easy it is to make changes onto your Python code and see that live on your local server, right? So for visualization, for plotting different graphs, all that I've done is I've done st.pyplot, and I have sent the matplotlib visualization as a parameter to it. And you will get all the beautiful visualizations onto your website. So working with Streamlit is extremely simple. We built this entire end-to-end tool within a weekend, and without having any background knowledge of HTML or CSS. So if we can do this, I'm pretty sure you can do it much better. So that is mostly about it. So all that we have done in this particular talk is we have pre-processed the data using pandas. And if your data is really huge and if it's distributed over different databases, you can go ahead and use task. We have built a churn analysis model using Lifelines package. And then we have built this very beautiful website using Streamlit. And finally, we have deployed all our changes onto Heroku. So these are some of the references that you can uh, go ahead and explore if you're really interested to know more about this algorithm, more about this product. All right, and that is all about it. I hope you really enjoyed this talk.
Thanks, everyone. We'll stick around for the next 5-10 minutes. Happy to take any questions that you have.